We're going to look at example 2 and find the theoretical probability. And to do that, we're going to look at a situation where a t-shirt company has made t-shirts. And these t-shirts come in either green or in red. And they come with beautiful eagle decorations on the front that you can either get in gold or you could get them in silver. Okay, let me complete my table. And they have 10 green shirts with a gold emblem, 8 green shirts with a silver emblem, 6 red shirts with a gold emblem, and 6 with a silver. And that's what they have in stock. Somebody goes there, and these are all in a pile, and you can imagine this person's wearing a blindfold, reaches into the stock, pulls out a shirt. What is the probability that the student chooses a red shirt, a red t-shirt? What is that probability? Well, we looked at the equation for theoretical probability as the probability of event A, and so probability of the red shirt is the number of favorable outcomes. Well, a number of favorable outcomes mean the number of red shirts in the pile divided by the number of total outcomes, which is the total shirts in the pile. Okay, we want the red shirt, so it's favorable, and the number of total shirts in the pile. So what is that number? Well, we have 12 red shirts, and how do I know that? Well, because 6 plus 6 is 12, and we have actually 18 green shirts, so we have 30 total shirts. So 12 favorable outcomes. You can get 12 red shirts in that pile out of 30 total, which gives us 2/5. So the probability, you could say 2 ways. You could do it as a ratio. It's a probability of 2 out of 5, or you could express it as we did in the previous example as a percent, a 40% probability. So that is finding the theoretical probability. Let's look at another example of finding that, and let's see. And this is experimental. So let's see. This is example 3. It says the spinner. Oh, I always love drawing spinners. Let's see. We have a spinner. Let me see how round or not round I can make my spinner. And we're separating it into 4 sections. Here we go. And here's my little arrow, right? I'm gonna spin this, and it's gonna go all the way around. And it can go to yellow. Okay, it can do yellow and green. I guess they're calling that red. Looks more orange, but we'll still call it red. And blue. Let's see. Where's my blue? Here it is. All right, so I've got my spinner set up. The spinner was spun 20 times. So when you're looking at your experimental probability, just a reminder that that was number of successes. So you got to keep that in mind, number of successes over number of trials. Now there's how many tries you do. Well, they're telling you the number of tries is 20 times. They're spinning it 20 times, okay? So the table shows the results. So let me draw the table underneath the spinner. And let's see, we have 1, okay. So we're gonna do, so when we spun, we had, it hit the red spinner 5, it hit the red section 5 times. It hit the green section 9 times. Hit the blue section 3 times. And it hit the yellow section. I may have to write that in another color because yellow just doesn't show up 3 times also. So let me just circle that so we know that this is yellow. All right. So for which color is the experimental probability of stopping on the color the same as the theoretical probability? So for which color is what actually happened in practice, right? The experimental probability, the same as one would expect in theory. Okay, so this is experimental. So what's the experimental probability of falling? Let's see which, on red. Okay, so this is going to be the experimental. Right? Well, it fell on red 5 times out of a total of 20. So that's 0.25, right? Here it fell 9 times out of 20. And here it fell 3 times out of 20 and 3 times out of 20. Okay. Let's see. So this is experimental. Let's try theoretical. Well, theoretical, if you remember, was the number of favorable outcome. So P equals number favorable over number total. In other words, the number that the color you want over the total. So this is theoretical. Okay, so theoretically, what should happen? Well, theoretically, you have a 1, right? How many chances out of 4 do you have of landing on red? Well, you have 1 out of 4, right? And you have 1 out of 4 of landing on green, and 1 out of 4 of landing on blue, and 1 out of 4 of landing on yellow. In other words, the theoretical probability is going to be the same, but the experimental probability for each was different. And the only one that ends up being 1 out of 4 for both experimental and theoretical, and I put this as 0.25, but I should just put is the red. So I would circle and say for red, right, the theoretical and the experimental are the same. So if you're looking at the correct answer, it would be A in the example because it's multiple choice. All right, so that is example 3. And we're gonna finish off doing the last example in the book, which is example 4. And this, to define that, we're gonna talk about odds. Now, odds are slightly different than probability. So the theoretical probability, again, is number of favorable outcomes over number of total possible outcomes. Odds is slightly different you have two versions of odds. You have odds for, and you have odds against. Now, when you're looking at odds, you're looking at favorable versus unfavorable outcomes. So when you do, so if I was looking at a coin, right, and I'm tossing my coin, and I say I want heads, or I specify heads. Well, if it turns up heads, that's a favorable outcome. If I get tails, tails is my unfavorable outcome. Okay? So when you're talking about odds, you're talking about favorable versus unfavorable instead of favorable over total. So the odds for, or odds, I should say, in this the proper term is actually in favor. I'll write it correctly, in favor. Odds in favor is the number of favorable outcomes over not the total outcome, but the number of unfavorable. And the odds against is the reverse. It's the number of unfavorable outcomes over the number of favorable outcomes. Now, how does that actually work in a problem? Well, let's look at our spinner example. Okay, we just did the spinner, and the probability, right, of landing on a red was 1 out of 4, right? Because the spinner was separated into four equal parts, and it could land on red, blue, green, and yellow, right? Well, odds in favor is different. Odds in favor, number of favorable outcome is red, right? So we're gonna actually, this is landing on red if it's a spinner. You still only have one red out of, but instead of saying it's out of 4, the unfavorable outcomes, and I'll just redo the spinner real quick. I'll just put the spinner back up so you can see. Here's my spinner. I'm saying my favorable outcome is red, but I have 1, 2, 3 unfavorable, because if it lands on blue, yellow, or green, I don't like it. It's not favorable to me because I won't get my money. I want it to land on red. So it's 1 to 3. The odds against landing on red is 3 to 1, because I'm saying the odds against, I have my unfavorable options, 1, 2, 3, over my 1 favorable option, okay? So let's look at one problem and then we're done. So again, we have a spinner in example 3. Actually, we just talked about it, but I'll just do it again. Here's our spinner, and I won't color code it. I'll just say red, blue, green, yellow. What is the odds against green? What are the odds of landing on green? Well, actually, I always have to put an arrow with a spinner. It just doesn't look right otherwise. Well, if it's odds against green, my unfavorable outcomes are red, yellow, and blue. So I have 3 unfavorable outcomes, but I have 1 favorable outcome, which is green. So the odds against green are 3 to 1. Okay, that is the end of 13.1, and I'll see you tomorrow for 13.2.